Hello everyone, welcome to our channel. Okay, now we are going to be learning redistribution. So route redistribution. So now we are going to redistribute routes from OSPF into UGRP and the UGRP into OSPF. So the redistribution is a way to exchange routing information between two autonomous systems instead of using PGP. Okay, so now, for example, this red color, this orange is a site, choose a company, for example, and the blue color also a company, and enterprises. Okay, so now the enterprise, for example, blue, the enterprise blue wants to share its routing information with enterprise orange. Okay, and the enterprise orange wants to exchange its routing information with enterprise blue. So instead of using PGP, they have decided to use redistribution, because if they advertise PGP, the routing information via PGP, the routing information will be advertised globally. So everybody can see their routing information around the world. So instead of hiding, or for we can say privacy, they want to exchange the routing information between them. Okay, so mm, without making any anonymous person know their routing information. So now I'm going to show you the interfaces. So the router 2 is the ASBR, because it located between OSPF and the EAGRP, between two autonomous systems. So let's open the console. Here you can see the interfaces on router 2, interface fast Ethernet 0/0, so 1.15, and fast Ethernet 0/1, 2.2, and router 3, first Ethernet 0/0, 202.2.3, and we have three loop packs on router 3, 3.3, 5.5.5, and 7.7.7. And in router 1, on router 1, we have first Ethernet 0/0, and the IP address for the interface is 150.1.1.1, and we have three loop packs, 1.1.1.1, 2.2.2.2, and 4.4.4.4. So this is our scenario. You can see the topology. Okay, now I'm going to configure OSPF on router 1 and router 2, and I'm going to configure EUGRP on router 3 and router 2. Okay, then I will do the redistribution on router 2. Okay, first config T, okay, the command to enable OSPF router or SPF. Then the autonomous system, we are going to give the autonomous system number 1. Then I'm going to advertise the network. So I'm going to advertise all the interfaces, including loopback interfaces on router 1 into OSPF. So the command to advertise all the interfaces on and router 2 OSPF is 0.0.0.0, and the wildcard mask also 0.0.0.0, and the area is 0. So configuration on router 1 is done. Let's go to route 3. So on route 3, I'm going to enable EAGRP. So let's enable EAGRP, router EIGRP in the autonomous system number 1. Here also I'm going to advertise all the interfaces into EIGRP. So 0.0.0.0. Fine. Okay, let's go to router 2, config T, and router ISPF 1. So network. So I'm going to advertise the 100 network, sorry, the 150 network. Actually, the IP address is 150.1.1.0/16. Okay, 150.1.1.15, then the wildcard mask. So what I'm saying here is these octets should match. So 0 means 150, this octet should match. Then again 0, this octet should match. And third octet 0 means third octet also should match, and 255. So fourth octet did not match. Okay, so then the area 0. Then router, here you can see loading to 4. So we have neighbor adjacency now. We probably got the routing information, okay? EIGRP, autonomous system 1. Here I'm going to advertise the network 200 to the 2.2 and the wildcard mask 255. Let's see. Here you can see the neighbor adjacency, new adjacency 200.2.2.3. So let me show you. Show IP SPF neighbors. Here you can see 4.4.4.4 is the DR. So route 2 is the BDR. Okay, so next EAGRP neighbors. So this is our EAGRP neighbor 200.2.2.3. So this is our EAGRP neighbor. So now we have formed a neighborship with EAGRP and as well as OSPF. Okay, let me show you the routing information. Routing table. Show IP route. So now we are getting OSPF and as well as EAGRP. Here you can see on the 110 means OSPF. Okay, so OSPF and 90 EAGRP. So here you can see D means EAGRP and O means OSPF intra routing. Okay, intra route. Okay, and we have 1, 2, 3 routing updates from EAGRP and 3 routing updates from YSPF. Okay, so it's time for redistribution. Okay, let's and show PP route. Okay, so here you can see this is R1, route 1. So we are not getting any AGRP routes. Okay, on route 1 only we have directly connected routes. Okay, let me show you on route 3. And route 3 we have only directly connected routes. So you can see route 3, 5.5, 7.7, and 200.2.2. So these are directly connected. Okay, loop packs. So we are not getting any OSPF updates here on router 3. Okay, let's go to router 2. So this is router 2. Router 2 is our ASBR. So what I'm going to do here is I'm going to redistribute OSPF routing information into EAGRP and EAGRP routing information into OSPF. Let's do that. Okay, so on router 2 we are going to do this. Okay, because router 2 is the ASBR. Okay, so ASBR is doing the redistribution, okay, between two autonomous systems. Okay, now router ISPF autonomous system 1, I'm going to redistribute EGRP 1. So I'm redistributing EGRP into ISPF. Only class 4 networks will be redistributed. Just leave this. Okay, next, let's give this command router EIGRP 1, then redistribute YSPF autonomous system 1. Okay, let's go to router 1. Let's check the routing table. Here you can see we are getting EIGRP external routes. So E2 means external O for YSPF, and E for external, and 2 for type 2. So we are getting 3 network, 5 network, and 7 network. Okay, now we are getting external routing information. So here is the AD value 110 and the metric 20. Just remember this, the metric is 20. So external to one type 2. So type 2 means the cost which is advertised by the ISB or not. This cost, this metric value is not included the OSPF metric value. This value 20 is advertised by the ASBR. Okay, so let's go to router 3 and see the routing table. We are not getting the routing updates yet. Okay, let's go to router 2. Let's see, redistribute via spear. Then let's give some extra command. So I'm going to give match external. Let's see. Let's go to router 3 again. See the routing table. Still, we are not getting the routing update. Okay. So let's do one thing. So I'm going to give the metric value manually. So I'm going to manually set the metric value. So the EGRP is not taking the default metric value. So now I'm going to manually give the metric value, set the metric value. So metric, and here you can see the bandwidth in kilobits. So we have 100 megabit, okay, megabyte link. So 5 zeros, okay. Next, EGRP delay metric in 10 microsecond units. So I'm going to give 1. So the value can be 0 to 4294967295. It's really big. So I'm going to go with 1. Then EIGRP reliability metric where 255 is 100% reliable. So I'm going to give 255, 100% reliable. Then EIGRP effective bandwidth metric. So loading where 255 is 100% loaded. So I'm not going to give 255, I'm going to give 1 here. Then EIGRP NT of the path. So the value is 1 to 65,535, but mostly our MT value is 1,500. So this is enough. So now we have set the manual metric value. So we have manually set the metric value for EIGRP for external routes. Okay, so for external routes, we have set the manual metric value. Let's see whether we are getting, yes, we are getting the external routes. Here you can see D for EIGRP and EX for external routes. And the AD value for external routes is 170. And here we can see the distance, feasible distance. Okay, this is the successor. It is a successor for, so we have set manual metric value manually, okay, because the EIGRP was synced accepting default metric value. So we set it manually, okay. Next, let's go to router 1. So here is the router 1. So now I'm going to try to ping router 3. Okay, so I'm going to try to ping router 3. Okay, so ping 3.3.3.3.3.3. Let's see. Yes, I can ping 3.3.3.3. Okay, let's go to router 3 and try to ping 1.1.1.1. Okay, I can ping 1.1.1. So now we have internet connectivity. So, and we have the routing table and routing information here. Okay, let me show you the routing table again. Okay, here I can see the external. I think it's on router 3. These are the GRP updates. Okay, let's go to router 1. Okay, router 1 here. So now we are getting external 2 and the metric value is 20. Okay, so the metric value is 20 for external 2. Okay, now I'm going to change this into external 1. Let's see the metric value of external 1 and compare the metric value with external 2. Okay, so router OSPF 1 redistribute EIGRP 1 metric type. So metric type, here you can see 1 set YSP of external type 1 matrix and 2 set YSP of external type 2. So by default, YSPF uses external type 2. If we want to use external type 1, we have to manually set it. Okay, so I'm going to manually set metric type 1. Okay, let's go to router 1. I think there was a mistake here. I have to configure this configuration on router 2. So wrong place. Okay, let's go to root of 1, sorry, root of 2. Exit root of OSPF 1, then redistribute EIGRP 1 metric type 1. Okay, now let's go to root of 1. Show IP root. Now you can see external type 1 and the metric value is 30. So before the root of 1 was getting external type 2 and the metric value was 20. Now external type 1 and the metric is 30. Here you can see the 30. So external type 2 advertises only the external metric value, which is given by the ASBR, but external type includes the internal cost or the internal metric. So external metric 20 and internal metric 10. So 20 plus 10, 30, E1. So if it is E2 or external type 2, only the external value. So the external value is 20 and 20 is advertised for external type 2. So external type 1, external metric plus internal metric for E1, and E2 means external metric only. So by default, OSPF uses external type 2, but if if we have external type 1 and type 2, so here the precedence is given to external type 1. Okay, so this is the difference between external type 1 and type 2 in OSPF. Next, let's go to root of 2. So now I'm going to create a metric, a route map. Route map. So I'm going to give the name, my name. So next, set. So I'm going to now, instead of giving metric, we can give, what is it called? Mapping. So default map. So I'm going to set default metric. Okay, default. Okay, interface. Let's try. I think I forgot the command. Let me try again. After set, okay, metric. There is a metric. Okay, it's going well. Everything is going. Everything was going well at the time. Okay. Okay, now I'm going to check the command. Yeah, I got the command now. Okay, set. Okay, metric. Set metric. Then the kilobit value. And next, the delay. Delay, let me give 1. Then the reliability 255. Next, see the EGP effective bandwidth metric loading. So give 1. Next, TU 1500. So now we have created a route map. So now let's go to route of YSPF 1. Sorry, not YSPF. It's EIGRP. So now redistribute YSPF 1. So now instead of giving metric value here, I can give remote. Okay, remote map. Sorry, route map. Route map. What was the route map name? Kavi. Okay, it is done. So we are also sorry, we can also give metric value by creating route map. Okay, so we have created a new route map instead of giving metric value. Okay, here, okay, let's go to route 3 and see whether we are still getting update. Yeah, still we are getting external routes. We're still getting external routes in the AD value. This is the another way to redistribute OSPF into UGRP. Yes. So this is the redistribution. I think this is enough for today. And thanks for watching the video. If you have any questions or doubts, please drop your questions in the comment section. There I'll be answering your questions and we'll discuss. Okay, so thank you. See you later.